Dear students, I welcome you for the today's lecture related to the types of agitators. Now, in the last class, we have already discussed what is the agitation. Again, we will revise that. The agitators are basically the machines used in industries for mixing liquids together. The purpose is to mix the liquids or mix the different phases is the basic purpose. And to fulfill this purpose of mixing, you need the different means. And one of the means of mixing is the agitator. Now, this agitation or mixing processes helps to promote the reaction of chemical substances, keeping them homogeneous. Liquid bulk during the storage increases the heat transfer. The different processes that is required like blending, crystallization, dispersion, suspension, all these mixing processes that is carried out. Agitation, that is nothing but forcing a fluid by mechanical means to the flow. Mechanical means, mechanical energy is, electrical energy is converted into the mechanical to the kinetic energy then. To flow in circulatory or the other pattern inside the vessel. So putting them into the shaking or stirring action. This technique mostly involves the agitation by stirring. In chemical industries, this agitation by stirring, that is the preferred one. The agitation is achieved by generating movement of the fluid or liquid phase, and this is because of the presence of the impeller. So impeller, that is going to help to move the fluid, that is going to stir the fluid, that is going to create the turbulence in the fluid. So these impellers, they are very important. Now, types of agitators, by proper terminology we will talk, it is the type of the impellers, not the agitator. It's a type of a impeller. In broadly speaking, it can be called as types of agitator, but when you go into the details, it is the impeller. The bulk can be composed of different substances, and the aim of the operation is to blend it or to improve the efficiency of a reaction by the better contact between the reactive products. So this is what the agitator assembly is: the motor, the speed reducer or the gear reduction box, then the mechanical seal or the gland seal to prevent the vapors from this vessel. Then the main important part is the shaft, and to this shaft the attached impeller. So there is a difference of the impeller. This difference of the impeller is going to be the different types. Rest of the assembly, that is your shaft, mechanical seal, gearbox and the motor, they will be there for every type of the agitator, every type of the impeller. However, the difference is that you are changing the impeller. The impeller can be different. Now when you talk the agitation vessel, so its working volume is this and certain headspace that is provided. Working volume is the actual liquid that is available. However, the vessel volume is the total vessel volume. Out of that vessel volume, the actual working volume is different. And there is a headspace that is provided. This headspace depends on the vapors that is to be accommodated in the vessel. So if it is the boiling points are low, then the headspace can be higher. So to accommodate the higher volume of the vapors, this headspace that is required. Then the industrial applications that we have already talked, that is blending, dissolution, dispersion, suspension, heat transfer, chemical reaction. Now coming to the types of the impellers. Impeller selection and design is done on the basis of flow pattern desired. This is the most important consideration in impeller selection, that is the flow pattern. There are two types of flow pattern, that is a radial flow pattern and an axial flow pattern. And because of these flow patterns, how the fluid that is behaving inside the vessel, how the fluid that behaves inside the vessel, and this fluid behavior that finally allows how the reaction that is taking place, how the heat that is getting transferred, how the process of crystallization that is getting held. So all these different parameters are affected because of this final flow behavior. Then the dispersion of solid, liquid or gases. Then it is associated whether the main function is that of the heat transfer or the main function is that of the mass transfer at the interface. That means interface is the contact surface area, interfacial surface area, that is the contact between the solid and the liquid. So the different types of impellers are paddle type, gate type, anchor, helical ribbon, turbine, propeller, marine and beater. All these are the different types of impeller. But the total assembly required is that of a motor, gearbox, sealing arrangement, shaft, and at the bottom of shaft or in the middle of the shaft you can provide the different impellers. So one by one we will see the different types of impellers. The first one is the paddle type agitator, paddle type impeller. All of you have seen these paddles of the cycle paddles. It is similar to those cycle paddles. So the two flat blades are provided, one at the another, and they move in this direction so that the fluid also is moving with this. The agitators whose impeller has small blade area, it rotates at a high speed, that is the turbine, marine and propeller. This turbine, marine and propeller agitators, they are having the small blade area and they rotate at a higher speed. If the blade area is small, they can be rotated at a higher speed. And they are your turbines, marines and propellers. However, if the area is higher or the weight of the impeller itself is high, then they are rotated at a slow speed. So the agitator whose impellers are large blade area rotate at low speed, that is your anchor agitators, paddle, helicals, and these are suitable for viscous medium or slurries, viscous medium or slurries, because it is at a slow speed. So this is the general paddle agitator figure. Now you can see in this figure the paddles they are provided similar to your cycle paddles. So it is like that. In this figure there are three paddles they have been provided at different heights. So in this paddle, diameter varies from 50 to 80% of the vessel diameter. Diameter of a paddle agitate impeller is 50 to 80% of the vessel diameter. The width of the blades varies from 10 to 25% of the paddle diameter. That means based on your vessel diameter, the paddle diameter is decided, and based on this paddle diameter, your blades of that paddle they are decided. This is the actual paddle diameter from here to here, and the width of the paddle is this thing, that is 15 to 10 to 25%. It is often used at low speeds. Low speeds means 5 to 100 rpm. They are utilized where gentle mixing or storage of liquids or slow settling slurries is required. It provides homogeneous agitation to the lower section of the tank. Provides the homogeneous agitation only in the lower section of the tank. That means it is around your paddle. So maximum solid removal from the tank in batch operation, there it can be used. But the paddle is unable to give the radial and axial flow, and the developed flow pattern is very poor, and so the mixing is inefficient. That is, we have talked the two flow patterns, that is the radial flow pattern and the axial flow pattern. Out of this, the radial flow pattern is slightly developed in this paddle type of agitator. However, the overall flow pattern developed is very poor, and hence the effectiveness of the mixing is also low. So it is application include the storage tank for clays. That means only you want to stir or simply keep them in the motion. That is where these paddles they can be used. That is storage tanks for clays, lime concentrates, etc. And also in the precipitation or crystallization processes, this paddle impellers they are used. The first figure that is showing the four blade paddle. At low speeds, mild agitation is obtained in an unbaffled vessel, which is baffled vessels and unbaffled vessels. At high speeds, baffles are used, since without baffles, the liquid is simply swirled around with little actual mixing. So to increase the process of mixing, you are providing the baffles. We have already talked the paddle agitator is ineffective because the developed are flow patterns are not developed properly. Since the good radial flow is present but little vertical or axial flow that is there. It is used with the viscous liquids where deposits on the walls can occur and to improve the heat transfer from the walls. Now next is the turbine impellers. Turbine resembles of multi-bladed paddle agitator, multi-bladed paddle impellers with shorter blades. That means there is a similarity between the paddle impeller and the turbine impellers. But these turbine impellers they can be used at a high speed for liquids with a very wide range of viscosities. The turbines usually have 4 or 6 blades. They are useful for good gas dispersion. The gas is introduced just below the impeller at its axis and is drawn up to the blades and chopped into the fine bubbles. So in this figure, you can see the turbines that is provided. This turbine impeller consists of fixed angle blades attached to the hub driven by the agitator shaft. Now this is the central hub and there is a disc that is provided to the hub, the disc that is provided, and to this disc the blades they are provided, and this hub that is attached to the shaft. This central part, that is the hub, and this will be attached to the shaft. So turbine impellers operate at low speed and are much larger than propellers. When it is compared with the propellers, its speed is low. However, when it is compared with the paddles, its speed is high. Propellers, their speed is around 1500 rpm. Paddles, its speed is around 5 to 200 rpm. So turbine, they are in between that. That is around 750 rpm or so. The turbines has an excellent feature in designing the flow pattern, hence the effective in viscous medium. That means the flow pattern, whether it's a radial flow or whether it's an axial flow that is generated, based on that the different flow pattern inside the vessel that is generated, and this is well developed in case of your turbines. Now what is axial flow and what is radial flow? The term itself talks related to the axial flow. That means it is parallel to the axis of the shaft, the vertical shaft that is there, and the flow that is parallel to the shaft. So here the fluid moves parallel to the axis of the shaft. Axial turbine impeller is used for chemical reaction, suspension of solids and miscible liquids. Then radial flow, that moves perpendicular to the axis of the shaft. That moves perpendicular to the axis of the shaft. That means when the blades move, the fluid moves in the outward direction. Now it is moving like this. So fluid that is moving in the outward direction, that is what the radial direction. It is perpendicular to the axis, perpendicular to the shaft. So the fluid moves in the outward direction like your centrifugal force. So it goes out and that develops the radial flow. That is, it is perpendicular to the axis of a shaft. So it is used for gas dispersion operation. Now there are different types of these turbine impellers. One is the flat blade turbine impeller, which is going to give you the purely a radial flow. Purely a radial flow. This flat blade turbine, because the blades are horizontal, so radial flow is moving in the outward direction. That is the radial flow that is developed. So the blades are mounted radially with the hub and the center disc. This figure shows the center disc. This is the flat blades with center disc. It is used for low liquid heights to diameter of the tank, that is H by D or L by D. If L by D is less than 1.2, then agitator located near the tank bottom. Location of the impeller, bottommost part of the impeller, where it is located. So it is 1.2 times the L by D ratio. Then if this L by D ratio is greater than 1.3, then you can use the two turbine impellers. The second type is the pitched blade turbine impeller. Now here a certain angle that is provided to the above flat blade turbine, flat blade impellers. That means instead of putting like this, I am giving a certain angle like this. That means a certain angle which is provided, this angle helps to move the fluid in the downward direction. This angle helps to move the fluid or to force the fluid in the downward direction. However, the radial action that is there also in the flat blade, radial action is there. In the pitch blade, that is provided with a certain angle, the radial plus the axial flow that will be developed. So both the flow patterns that is developed into the pitch blade turbine. Now look at your fan blades. They are also provided with a certain angle. That is why you get the air in the downward direction. And it also provides a slight movement in the radial direction also. That is why you get complete air room that is aerated. If it is only provided with a pitched certain angle, then you will get the airflow in the person who is sitting below the blades. That is for the pitch blade and the flat blade turbine impellers. Then there can be the curved blades also. The curved blade turbine creates a dual action, that is, it sucks and develops the radial flow. This design is used when relatively low shear is required, where the low shear that is required. There are certain materials where low shear, low force that is required, so that it will not get damaged. When abrasion must be considered and when many other variables are of prime importance. Then shrouded turbines for high pumping capacity. These are similar to your pump impellers. Pump impellers are provided with the curved blades, and to that it is having a certain binding to these curved blades, as you can see in the figure. So these are the different figures related to the turbine blades. Now the flow pattern that is generated. How the flow pattern that is generated. This is the turbine impeller showing the flow pattern. Now in the upper section, one loop you can observe, and in the bottom section, one loop you can observe. So such loops in the upper section and in the lower section, they are observed because of this axial flow movement. That means below the impeller there is a fluid movement which is generating a loop below the impeller. Similarly, the fluid that will be sucked from the bottom, from the upper section also, there is a circulatory movement that will be developed, and certain radial flow that is also provided. Radial flow, it moves or separates when it stuck to the wall. It separates in the upward and downward direction. Fluid moves and then it separates. Then these are the certain dimensions of the turbine. What will be the liquid height? What will be the bottom clearance? What will be the diameter of the agitator or impeller? Diameter of the tank? What are these baffle widths? What is the baffle gap? So all these different parameters, width of the blades. So all these different parameters are to be given thought while designing the different impellers. Now next is a gate type. Gate type, all their modifications from your paddle type. Anchor type, that is also the modification with the paddle type. The simplest is the paddle one. The gate type, a certain gate that is provided. A gate impeller is designed for materials of high viscosity. Viscous materials. It operates at a low speed. You can see the dimensions. It occupies almost the to the diameter of the vessel. So it will be the heavy one. So it has to be operated at a slow speed. It is the most desirable for shallow, wide tanks and wherever low shear is required. Next is a anchor type. The word anchor itself talks about the geometry related to this agitator, the anchor type that is provided. So it is used in large jacketed vessels where the high viscosity application is there, and it also operates at a lower speed because the viscosities are high, so the speed that is reduced, and it also occupies the vessel diameter. Anchors and vessel diameters are almost same, but there is a clearance between the wall of the vessel and the agitator and the impeller. So this clearance, that is of 6 millimeter from the wall and up to the 25 millimeter from the bottom section. Then these anchor impellers has the uniform or tapered cross section at the bottom. So power requirements varies directly with the impeller. Liquid height, what will be the viscosity, all these different parameters are considered for power requirement. The anchor agitator has a contour that matches with the tank. As the blades move, they generate vortices behind them. As the blades move, they generate the vortices in the behind them. Means when the blade that is moving, the vortex that is generated in the back side of this impeller. This is what your impeller. And the back side of this, there is a vortex that is generated. And the fluid move like this and will enter in this vortex, and there is a mixing that will take place behind this vortex, behind this blade. So as the blades move, they generate vortices behind them, creating the exchange of liquid between the bulk of a liquid and the liquid trapped between the anchor blades and the wall. So only which liquid is coming in contact? The liquid which is coming in contact with the blades and the liquid which is behind the blade. So there the mixing you can see in these anchor blades. So there are different types of the anchor blades. The plain anchor impeller, that is, these are not satisfactory for viscous liquids, as the mixing is only taking place behind the blades. So the number of blades they are increased. So the baffle that has been put incorporated to increase the turbulence. So that will make a anchor agitator with vertical baffles. This type improves the top to bottom liquid circulation. As the baffles at the center you can see they are provided. So this improves the flow pattern, flow circulation that is improved. Then next is the anchor agitator with wall scraper. As the diameter of the tank and the diameter of the impeller, there is a certain clearance that is provided. So you are going to put a certain scraper to wipe out the surface of the wall. To wipe out the surface of the wall, you are putting a certain scraper. That means if this is the wall, you are putting this as a scraper and you are taking out the material which is adhered to the wall. So wall will be scrapped, will be cleaned, and this will help to increase the heat transfer. And this is specifically important in case of your polymer industries. Polymer is very viscous, so it adheres to the wall and it gets degraded when the wall temperature is high. So it is very essential to wipe out all the polymer which is adhered to the wall, so that you will be able to provide the fresh polymeric material every time on the wall surface. So to prevent the degradation, the role of agitator in case of your polymer industries, in case of your food industries is very, very important. Then the anchor agitator with wall scrapers and baffles. So wall scrapers and baffles both are available with this anchor agitator. The next is a helical ribbon type. These are used in high viscous solutions. It operates at low RPM in laminar region. Viscosity is high, so it goes into the laminar region because of the low RPM. Then ribbons are formed in the helical path and is attached to the central shaft. These are the double helical ribbon. The B figure represents the double helical ribbon and the C, that is the helical screw. There is a difference between the screw and a helical ribbon. So it's a ribbon. B is a ribbon and C is a screw. Screw that is directly attached to the shaft. However, there is a clearance between the shaft and the ribbon. Then the helical ribbon agitator gives the gentle mixing and high top to bottom liquid circulation. This is what is advantageous in case of helical ribbon. Top to bottom liquid circulation, because it is like a helix. So the fluid which is at the top that moves with the helical ribbon and changes its position from top to bottom. So this is generating the high mixing in the vertical direction, that is the axial mixing. The power requirement increases as the pitch of the helical ribbon decreases. There are 5 types of helical ribbon agitator. The single helical ribbon agitator. This is what? A single helical ribbon. Now in intermittently this supports they are provided. Intermittently this supports to the single helix that is provided. Then there is a double helical ribbon So two helix that is provided. Then quadruple helical ribbon, the four helix that is provided. Then there is a screw, helical screw ribbon agitator. So screw and helix both are present in this figure. In this figure, it is only the screw that is provided. Screw is directly to the shaft, and helix, the clearance between the shaft and the helix. So these are the ribbon and the screw combination is good for mixing pseudoplastic materials and higher viscosity materials. So these are again special purpose helical ribbons where you can convey the solids with the help of these helical screws. Conveying of the solids that is also observed helps in case of the screw conveyor. So ribbon and the screw combination is good for mixing the pseudoplastic material and high viscosity materials. Such arrangement reduce the mixing time and has a very small effect on power consumption. Then helical screw agitator, it is useful for high viscous liquids. These are of four types, that is unbaffled centered helical screw agitator. It includes the mild swirling motion in the liquid and is thus not an effective mixing device. The liquid at wall remains almost stagnant. That is what the disadvantage with the helical screw. Liquid at the wall remains stagnant. The ratio of screw diameter to the vessel diameter varies between 0.25 to 0.8. This is the helical screw. Then the off-centered helical screw agitator. That means it is not at the center. It is moved towards one of the sides so that the turbulence that is created, and you are going to scrap the material which is besides the wall. By its use, swirling motion can be avoided and mixing time that is reduced. Then helical screw agitator with the baffles, it helps to reduce the swirling motion of liquid, create the turbulence and improves the overall efficiency. That is by providing the baffles. Now providing a draft tube. Same, the helical screw agitator with a draft tube that is provided. It incorporates the mixing again.